Hello everyone, I'm Frank. Welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Triple Trouble by Doc Logic, and here are the rules. We have normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Ooh, we can get a region here. This is the 9-cell region. We have thermometers where digits increase starting from the bulb. So as an example, you could have something like 2, not 0. Well, no, 0 is not valid. 2, 6, and 7. That would work perfectly fine because these digits must be continuously increasing from the bulb to the tip. We have German whispers, where digits on each green line have a difference of at least 5 to their neighbors. So, for example, if this were 3, this would have to be 8 or 9, because the only digits that are 5 or more away from 3 are specifically 8 or 9. We also have Kropke dots, where cells linked with a black dot have a ratio of 1 to 2, and cells linked with a white dot are consecutive, and not all possible dots are given. So, for example, if this were 3, this would, well, okay, that would have to be 6 specifically, because these digits must be in a 1 to 2 ratio. If, say, this was an 8, this would have to be a 7 or a 9, because those digits must be consecutive. And that's how Kropke dots work, and those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so the one that I see that starts off is in the upper left box and the lower right box. Where can a 9 be? In the upper left box, 9 can only be where it's not less than any other digit. And these are all less than every other digit. Than some other digits, shall we say. These 3 are obviously less than these 2. These 3 are less than that. These 2 are less than that digit. So this must be a 9, and this must be a 9 in the upper left and the lower right boxes. What else do we know? Where can 8 be? Actually, that's probably not the best place. Let's target this one. So this was an interesting thing here, where we basically tried to have... So 9 cannot be here, 9 cannot be here. 9 can also not be next to a black Kropke dot, because if it were, 9 is double of 4.5, which is not a digit. And if you double 9, you get 18, which is not a digit. So therefore 9 cannot be here, 9 cannot be here, and 9 cannot be here in this upper right box. So 9 has to be one of these 2 digits. Which means in this upper central box, where is the 9? It must be one of these 2 digits, because it cannot be that digit because it's less than that digit. Let's see. What are the unique possible digits here? Again, it could be 1, 2, 3, 4, 6, and 8 as possibilities next to the black Kropke dot. If this were a 4, this would have to guarantee 9 to be there, which is not possible because 4s can only be next to 9 on a German whisper line. So this can't be 4, which means 8 cannot be here. If 8 were here, that would force 4 to be over here. And that's not allowed because 4 has to be next to 9 on a German whisper line. If this were 3 here, that would force 6 to be here, and 6 has to be next to 1. Same here. If this is 3, it would have to be next to a 6 here for the black crop key dot. The 6 can only be next to 1 on a German whisper line, and the 3 can only be next to 8 or 9. Well, those two digits are never going to be consecutive, so this cannot be a 3-6 pair here. Also, yeah, if you have two unique digits on a German... Okay, so on a German whisper line, and I've said this many times, actually, so if you've seen this, I mean, if you've seen a lot of my Learn How to Sudoku videos, you'll see basically me talking about this. But on German whisper lines, you'll always alternate between low digits, which are the digits 1 through 4, and high digits, which are the digits 6 through 9. And the reason why is what digits can be next to 1 through 4. 1 can be next to 6 through 9. 2 can be next to 7 through 8. Sorry, 7 through 9. 3 can be next to 8 or 9, and 4 can be next to 9. So any digit from 1 through 4, you'll always have a digit next to it that's from 6 through 9. So perhaps the easier way of actually thinking about this is these two digits are consecutive. You can't have a 5 ever on a German whisper line, because if you have a 5, subtract 5 or more from that, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to it, you get 10 or more, which is not a digit. So you'll always have two digits, if they're consecutive, and they both are in a German whisper line, they have to be the same set. They're either both high or they're both low. And again, 1 through 4, the low digits must be next to a high digit on a German whisper line. And a high digit, similarly, must be next to a low digit on a German whisper line, right? 6 can only be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1 through 4, but those are all lows. So these digits must be the same set, essentially. It must be in the same set, right? These two digits then must be the opposite set of these two digits. So they must be the same set as each other. So we're going to mark this as just one type of set. We'll mark this as the other one. So this must be the opposite of the pink. This has to be pink. This has to be orange. And then we can always alternate between these. This is pink. This is orange. This has to be pink, which forces these 4 to be orange. So that's the best way of doing that. That means in the rest of this lower left box, the rest of the digits cannot be set orange, right? Because if it's set orange, it doesn't work. Also, we know if you have two unique digits, or if you have two digits that are in a 1-to-2 ratio, the only way they can be of the same set, if it's low 1 through 4 and high 6 through 9, is if they're both low. So the oranges all have to be low, and the pinks must all be high. So if you have a low we have in the lower left box 4 lows already here. That means that we cannot have a low in the rest of that box, right? Because all the digits 1 through 4 must be filled in those 4 cells. So this must be a high. In this set, we have a high next to a black crop key dot, but you can't have two highs on either side of a black crop key dot, right? If you try to double 1 to get another high, this doesn't work, right? So you have 6, it would double to 12, 7 doubles to 14, 8 doubles to 16, 9 doubles to 18. So this always has to be low, which means if we alternate again, this is high, this is low, this is high, and this is a low. Well, 9 can no longer be here because it's that would be a low digit. So this can't be 9. Which means where is the 9 in this upper right-hand box? It must be here. 9 can only be next to 8. So this must be 8 here. This is 9. This is 1, 2, and this is 1, 2, or 4. So one of these digits must be a 2. This digit is either 6 or 7 to be a high, and this digit cannot be any digit but 1, 2, 1 or 2, right? Because 3 has to be next to 8 or 9, and this is 6 or 7. 4 has to be next to 9, so this can't be. So this has to be a 1, 2. Well, in this upper right box, we have a 1, 2, 1, 2 pair, which eliminates 1 and 2 from the rest of the box. This can't be 1 or 2, so this is 4. 4 is only in a 1 to 2 ratio with 2 out of 1 or 2, so this is 2, this is 1. This must make this a 3. So, this is 1, this is 2. The remaining digits in the box are 5, 6, and 7. So we'll put 5, 6, and 7 there. The low digit that must be next to a high digit in a 1 to 2 ratio can only be 3 or 4. Because those are the only ones next to a high digit. And this is 6 or 8. Similarly, this is 3, 4, and this is 6 or 8 here. This digit is next to 4 other unique digits on a German whisper line, and it's a high digit. So it has to be 9, right? That's the only high digit that can be next to 4 unique digits. So this is 9. 9 can be next to, this is next to 6 or 8, so this is 1, 2, or 3. And these are 1 through 4, obviously. 6 or 8 can be next to 1, 2, or 3 here. We have the digits 6 through 9 here. This can't be 6 or 7 because it's next to a 3 on a German whisper line. This has to be 1 or 2 to be next to 8 on a German whisper line. This must be 1 or 2 to be next to 6 or 7 on a German whisper line. Okay, what else do we have? Remaining digits in this lower left-hand box are 5 through 8 because we already have all the lows. This then must be 4 through 9 to be consecutive with 5 through 8. 1 cannot be here. 1 has to be one of these two digits here. So similarly to the 9 that we did earlier at the very beginning, where can the 1 be in this upper left box and this lower right hand box? It can only be on a bulb because then it would be the lowest digit. If you were anywhere else on the thermometer, it would always have a digit that's smaller than it, which is not possible. So either this is 1 or this is 1, and either this is 1 or this is 1. Okay. Okay. In this upper central box, we know 9 has to be one of these two digits because of where the 9s are in rows 2 and 3 and the thermometer here. In the central box, we know this is 1 through 4. This has to be 1 through 5, and this has to be 1 through 5 because we have all the high digits in this box. And this box cannot have this cell cannot have a 9 because it's next to a black Kropke dot, and 9 can never be next to a black Kropke dot in normal Sudoku because of the reason that I gave, right? 9 is double of 4.5, which is not a normal Sudoku, which is not a digit, and 9 doubled is 18, which is not a digit. So 9 has to be in the central box, one of these 3 cells, which is in columns 5 and 6. And in this upper central box, it also has to be in columns 5 and 6. Well, that means we know where the 9s are there. So in columns 5 and 6, we have accounted all the 9s, right? So either this must be 9 and this must be 9. That means 9 cannot be in the rest of columns 5 and 6. So in this lower central box, where is the 9? 9 can't be here, 9 can't be here, 9 can't be in the column 5 or 6. So 9 has to be here. And 9 is only consecutive with 8. So this is 8. This is 7. This 8 eliminates 8 here. So this is 6, and this is 3. That's 3 in the corner. We celebrate because we know we're getting close to solving it. That also eliminates 3 in the rest of the box. This can't be 6, 7, or 8, so this is 5. These two digits are consecutive, so it's and we know 1 is here. So 2 cannot be here. 2 would have to be consecutive with 3 or 1, and those are not allowed. So 2 has to be one of these cells here, 2. 2 obviously can't be here because of the 2 in the column. Okay. What is this, the 2 digits next to this black Kropke dot? If we try to have 1, 2, 2, 4, or 4, 8, the problem is 1, 2 would eliminate all possibilities for that cell. 2, 4 would eliminate 2 and 4 here, and both of these would be 1, which would mean we have a repeat in the column, which is not allowed. And 4, 8 doesn't work because 8 is already in the column. So this must be then the pair of 3 and 6. So this is 3 and 6. 3 and 6 is here. Where is 3 and 6 in column 2? Can't be here because of the 3, 6 pair in the box. Can't be here because of 3 is 6 in the box. So this must be a 3, 6 pair somewhere in this upper left-hand box. And 3 cannot be here. 3 and 6 are next to 2, 4, 5, or 7, right? 3 can be next to 2 or 4. 6 can be next to 5 or 7. But 5 and 7 can't be next to a black Kropke dot. 5 is doubled 2.5. 7 is doubled 3.5. If you double 5, you get 10. And 7 doubled is 14. So this has to be 2 or 4, which forces this to be 3, which forces this to be 6. Okay. 3 cannot be any of these. So 3 can be here or one of these two. 6 cannot be here because of the 6 in the row. This 2, 4 can be next to 1, 2, 4, or 8. If this were 1 here, that would force 2 to be both here, to be consecutive with it, and here to be in a 1 to 2 ratio. So this can never be 1. If this is 2 here, this would be 4, so this would be 1, so that's valid. If this is 4 here, this could be 2. 2, 4, this would not be 3 because of the 3 there, so this must be 5. Also, if this is 2 here, and this is 4 here, again, it can't be 3 because of that 3. If this is 8 here, this is 4, this could be 7 or 9, but it cannot be 7 or 9 because of the 7 or 9 in the column, so this can't be 8. This becomes a 2, 4, 2, 4 pair, which eliminates 2 and 4 in the rest of the row. This can't be 4, so this is 3. This can't be 2, 4, or 3, so it's 1 or 5. This 3 is only in a 1 to 2 ratio with 6, so this is 6, which makes this a 1, because 6 can only be next to 1 on a German whisper line. So these are both 1s, which means this can't be 1. This is a 5, which makes this a 4 to be consecutive with it, which makes this a 2. This 1 eliminates 1 here, so it's a 5. This can't be 1, this can't be 1, 3, or 5. We have the remaining digits in the left central box as 1, 7, 8, 9. 9 cannot be here. 1 can't be either of these because if 1 were either of them, it's not consecutive. It can only be consecutive with 2, and we already have a 2 in the box. Therefore, this is 8 with 7 or 9, but what digits can be next to a black Kropke dot? It can only be 8. So this is 8, because it can only be next to a black Kropke dot, and 7 and 9 cannot be. So this is 8, this can't be 8, this can't be 8. 8 is in a 1 to 2 ratio with 4, so this is 4, which makes this a 1, and this can't be 1 here. This is a 7, 9 pair, which eliminates 7 and 9 in the rest of the box. So that's 1 here, which means this can't be 1, this is 2. This 2 can only be next to 7, 8, and 9 on a German whisper line, so this is 7, and this can't be 6. Well, we already knew that anyways. This 2 eliminates 2 here, so this is 4, which makes this a 2. This can't be 1 or 4, so this is 2. This can't be 1 or 2, so this is 4 because of the 1, 4 in the column and the 2, 4 in the column. The last remaining digit in column 1 is a 2. The remaining digits in column 3 are 5 and 7. The remaining digits in column 2 are 3, 6, and 8. But 8 cannot be greater than less than 5 or 7. So 8 cannot be here. Therefore, this must be an 8 here. Let's see, what else do we have? We have either 4, 5 or 5, 6 here, right? 1 and 2 can't be here. We can't have 7, 8, or 9. The only possible combinations that are consecutive are 4, 5, and 5, 6. Either way, you need a 5. 5 can't be here because of this 5. Therefore, this is 5, and this is 4 or 6. This is 3. It has to be next to an 8 or 9 on a German whisper line. We have an 8, 9, and this 8 eliminates 8 here, so this is 9, which makes this 8. Therefore, this can't be 8 or 9. Therefore, it's 7. The remaining digits in row 4 are 3 and 5. This can't be 7 here. This can't be 7 here. Remaining digits in row 3 are 1, 2, 5, and 6. But this can't be 2. This can't be 1 or 5. Remaining digits in row 5 are 4, 6, 7, 9. This can't be 7 or 9, and this can't be 9 because of the 9 in the columns and the 7, 9 in the columns. Remaining digits in row, well, where is the 1? In row 6. 1 cannot be either of these because it's greater, this would be greater than 3 other digits. So these can't be 1, therefore this must be a 1 here. So this is 1, this can't be 1 or 2. Where is the 1 in this lower right-hand box? It must be here. Where is the 2? It must be here. So this is 4 or 6 here. These digits are 7, 8, or 9. And this can't be 7 or 9 because of the 7, 9 pair in the column. So this is an 8, which means this can't be 8. Let's see. Both of these digits are greater than a 5, so it has to be 6, 7, 8, or 9. This can't be 8 or 9, so this has to be 6 or 7. Those are only both greater than 5. If this were 7, that would make this a 6, and that would not be greater. So this has to be 5, this has to be 7, which means this can't be 6, 7, or 9. This has to be 8, because it has to be greater than the 7, and then therefore this must be a 9. So this was 7, 8, 9. 5, 6 is not less than 5, so this has to be a 3, which makes this a 6. This 6 eliminates 6 here, so it's a 5, which makes that a 6. This can no longer be 6 here. That leaves the remaining digit here as a 3 in row 1. We have the remaining digits in, so this can't be 6 here in row 3, so this must be 2, which makes this a 1. This can't be 1 or 6, so this is 5. The remaining digits in row 2 are 4, 6, and 7. This can't be 7. This could be any of those. Okay. In column 7, we have 4, 6, and 7 remaining, and this can't be 4 or 6, so this must be a 7 here, which means this can't be 7. We now have in this right central box a 4, 6, 4, 6 pair, which eliminates 4 and 6 in the rest of the box, so this can't be 4. This is a 7, 9 pair here. The 6 eliminates 6 here, so this is 7. This can't be 7 then. In the rest of column 4, we have 1 and 3, but this can't be 1 because of the 1 in that row. So this is a 3, this is a 1. These digits are consecutive. You can't have 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. You could have 6, 7 be consecutive, and 7, 8 be consecutive. Either way, you need to have a 7. So this has to be 7 here, because 7 cannot be here. This is a 6, 8 pair. We have 4, 6, and 8 here. 4 cannot be here, and 6 cannot be here. in this cell because of the 4, 6 in the column. So this is 8, which makes this 6. This must be 4. This 6 eliminates 6 here, so it's 4. This is 6. This has to be 4. Then this leaves that as a 2. This leaves that as an 8. This 4 eliminates 4 here, so that's a 6, which makes this 4, which makes that a 6. This digit must be smaller than 4, and it cannot be 1 or 2, so this must be 3, which makes this 5. This 3 eliminates 3 here, so it's 5 and 3. This digit is greater than 8, so it must be 9, which makes this 7, which makes that 9, which makes that 7. And that's how you solve it. Yeah, pretty straightforward. Just a normal use of German whisper lines and black Kropke dots. And the white Kropke dots. The logic flowed very well, though. That's one thing aspect. Yeah, I think I should have explained more of my logic behind this of attacking what I did. I do like tackling essentially like German whisper lines because it does give you a sort of an easy way of restricting certain things, right? So knowing that it always alternates between low and highs is very useful on normal Sudoku puzzles. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.